Very good afternoon, everybody. Those who are from India or nearby countries, and good morning, good evening for people who are from different parts of the world. It's lovely to interact to a lot of people. However, I had a good introduction about the course beforehand, about what it's going to be with the person who has connected to me, Madam Ikta Malik, and talking about what are we going to do today. Sorry, I have a little bad throat, so I'm expecting all of you to please forgive me for that for the day. It's like beyond control. So what are we going to do today? Before I get into that, I'll take just half a minute to introduce me, as Raksha has did it very wonderfully. Keep in mind that the session is not about me, the session is about the topic. But what among that, what about my experience is required for the session, I'm just going to bring in those points. So I am a corporate trainer. I have spent most of my time training people. I might look very young, and actually I'm very young, but I have spent a lot of time in recent past working with people from Cisco, Amazon, QA, Simplilearn, and lot more companies. So that's what make me comfortable to teach on this topic here. And my primary domain has been machine learning and data science. Why this information is required to you? Just one second. Okay, sorry. Yeah, why this information is required to you is just to bring in a point that whatever I'm going to say today might go a little against your standard belief. And I'm talking about those who are only students. Those who are working professionals may find my words very in line with their experience. But those who are students, you may find my words going little against your standard beliefs about machine learning or about data science. But I want you to trust me, or I should say, just note down these points and do your own research before you believe me on any of the point, because whatever I'm going to bring in may contradict your educational knowledge and may give you a perspective from the industrial viewpoint also. I saw the poll result in the very start, and I found there are people from different kind of experience. There are people from 6+ years of experience. There are people from 2 to 3 years of experience. Honestly, I don't even have 6+ years of experience myself. So it's glad to have an interaction with you. Don't take it like a training, take it like a discussion. And please do contribute from your side also in whatever way you can. Raksha, just a quick question. Can people speak up by themselves, or do they need any kind of permission from our side?
Yeah, actually, they can interact with the chat only and
Okay,
Q&A
perfect.
section. Yeah.
Perfect. So I will be keeping chat posted on my screen all the time. So whatever question you have, please come up on chat, and whatever discussion, whatever point you want to add on. I just shouldn't just limit you to questions. If you want to add on to any point, please come up. Coming down to the topic, like why this topic, what this topic has to do with this data hour. So I was thinking, like, what can I do in 1 hour? What can I add on to people who may or may not know machine learning? So I came up with this topic that there are a lot of students, and machine learning being the buzzword around industry. Like, you go to any coaching center, tuition center, if they deal with IT across the globe, they must be dealing with Python and machine learning, which is making machine learning seems so easy, but it is not. Like, it may look very easy if you are looking from a college perspective, but in the industrial scale, it is not. It is one of the nightmare, and few steps in that are one of the nightmare in across the industry, which is about data. So I am going to talk a lot about how do I, being a developer, or how do I, being a trainer who interact with a lot of developers across industry, from the small startups to all the way Amazon and Cisco, what are the challenges this this world of machine learning engineers face in the real world? And if you're planning to be one of the machine learning or data science engineer, you're most likely going to face the same challenges. And I expect you to have your paper pencil or a notepad, or some digital notepad or something be with you, or to keep with you, and to type down or write down whatever we are discussing, at least the bullet points, so that you can think on that and research on that later. In this entire hour, I will not be teaching you anything. I will not be coming up with a course kind of content that this is topic one and this is topic two. No, it's not possible. But I will be giving you a lot of tangents to think upon. I'll be giving you a lot of viewpoints, a lot of perspectives, which if you spend some time on, they will really be going to help you out. Okay, so I'll start my question with a very simple and a cliche query here, that what is machine learning? I believe most of you have the idea, even if you have taken a professional course or not, you must be having an idea of what is machine learning. Please put down your message on chat. Let's see, what do you understand by the word machine learning? Everybody, like, do not worry about whether it is correct or incorrect. Whatever you think is machine learning according to you, please put down. Okay, I got one more message. It says it's by Chandrasekhar. It says learning from data. Another one is by predicting and analyzing using data analytics. Okay, trying to predict. Okay, sorry. How the machine learns from its operation and does it iteratively. Give machine the capability to act and think like human. Okay, perfect. Perfect. I'll give you a quick example which makes everybody on the same page about this question. What is machine learning? Imagine a kid, a very young kid, and a kid which cannot even walk and just struggling to crawl, and have very little common sense, no such belief systems, etc. And the kid is crawling, and on a table there's a cup of tea placed, cup of tea or coffee or anything which is hot, and it is placed up there. And the kid accidentally comes in and touch that cup, or the cup, the tea liquid gets spoiled onto his or her hand. Okay, what it is going to do to that kid? The kid doesn't know that this is hot. The kid doesn't know the meaning of the word hot. The kid doesn't know the meaning of the word tea or coffee or liquid or gas or anything like that. The kid just know one thing, that this is a bad experience. Not in English, but in terms of feeling, the kid realize that this is a bad experience. And the next time, whenever that kid sees something like a cup placed on a table or anywhere, some sort of steam coming out of that, the kid will restrain not to touch that object. Even that kid had no knowledge about temperature, physics, thermodynamics, and all the concepts you know as an engineer. The kid still understand that this is bad and this is good. That's the level of intelligence that kid is possessing at a young age of maybe 3, 4, 5 months. Okay, or could be as young as 1 or 2 months. And we, as we grow older, we keep on bringing up our intelligence on the next level. Now, where this intelligence is coming from? How can a kid which is just 2, 3, 4 months old, how can a kid possess that knowledge? Because of a lot of genetic information placed in that kid's mind or neural system even before his or her birth. If I say I am like 25 years old, my brain could be having information millions of years old because of my parents and grandparents and great grandparents and so on. That's why so many things comes naturally to us. We learn walking in the age of 1 year, and it's one of the very complex operation because of a lot of genetical information placed in our brain. Make sense? Now, when we talk about machines, machine is just a piece of hardware that's built from scratch, has no genetical information, has no brain, has no neural network. But if by the help of softwares, we can help that machine to possess some sort of intelligence to decide what to do when and what not to do when, is called as artificial intelligence. There's a very clear difference. If you have worked on any programming language, you may argue that, Harsh, this is the same thing that can be done with if else based programming, right? Switch case or if else or else if, all of them in every programming language. Yes, but the difference is, in if else, you are the one who decide what to do and machine does that. You write that if x is greater than 5, do that, else do something else. Okay, but in case of machine learning, you let the machine decide what decision to take and when. That's the classical difference between uh, rule based programming and intelligence based programming. So, given a quick brief about what is machine learning, it is the ability, it is one of the ability for machine to take decisions without hard coding those decisions. If I give you one more quick example, which will make a lot of sense in your mind, when you learn driving a car or a bike or a cycle or anything, like recently I have learned a couple of years back driving how to drive a car, and my elder brother was teaching me up. Whenever we were going on a road and I was driving, that person, my brother, was guiding me with broader inputs. Like, he was saying that, okay, there's a higher traffic, You take a left, and there's a higher traffic on the right side, you go straight and then you go right, etc. Nobody was giving exact numbers like turn 80-degree right, walk for 5 seconds, and then turn 70-degree left, and then put your speed below 25 kilometer per hour or anything like that. But when you work with machines in the classical traditional environment, you have to hard code everything. You cannot instruct the machine that go a little slow. There's no meaning of a little slow. There's a meaning of 20 kilometer per hour or 22 kilometer per hour or 15 kilometer per hour. You need to hard code. But with machine learning, as Tesla and a lot of new companies are doing up that task, you can bring up the form of decision making in the machine itself. That's all about artificial intelligence and machine learning in a very general and simpler way. Okay. I got a question, or I'll take up the questions a little later. Let me have my points cleared up beforehand, and whatever questions will be there, I'll just keep taking it up because there's so many of them walking around the chat box, and it will be really difficult for me to take up in synchronization. Okay, so what are we going to talk about is how do you approach a problem and how do you design such kind of solution. The very first thing is about understanding the requirement. What is the requirement? And understanding the possibility. I'll give you an example. My name is Harsh. Can you please tell me what is my mobile number? You seem to be very intelligent. Forget about machines. You as a human, all of you must be like above 15, 16 years of age, I believe. Okay, so few of you can be 25, 30, 35 years of age. You're very intelligent. You have done a lot of good work. Look up on phone book. I don't think so. That's any kind of intelligence. That's like a processing. Let me ask you another question. My name is Harsh. Can you tell me what's my blood group? I got the silence, right? That's the answer that says that you cannot. Even I cannot, right? There are scenarios like this which are not solvable. But if I say you that, hey, can you look at my face? Can you look at my video feed? And can you predict what will be my age? You can. All of you will come down a number of 22, 23, 24, 25. And that's primarily correct, right? So you can do some kind of tasks considering it intelligent, and you cannot do some kind of task considering it like a vague guess, rather just a vague guess, not any form of intelligence. So there are few things which have some sort of correlation. This is called as correlation. My facial image, my video camera feed has something to do with my age, because you're looking at my facial features, you're looking at the wrinkles, you're looking at the skin tone, you're looking at a lot of facial features like we do, and age is a derivative of that. But my blood group is not a derivative of my name, so you cannot predict that. The very first thing we need to understand in approaching any machine learning or any intelligence based problem is it solvable? Is it feasible? Does it have correlation? If Amazon comes to me and say that, hey, we have this data in this, so many people are coming in and they are purchasing and they are doing transactions, I want to know next year what will be my total sales. Maybe there is some sense we can predict, because based on past trends, based on current trends, we can predict what will be the sales in next year. But if Amazon comes to me and say that, hey, we are going to change our logo, and looking at our data, can you please tell me what color we are going to bring in? Not the question like what color we should bring. If they are asking you what color we are going to bring in logo, it's a not correlated data or not correlated answer to predict for. So the very first thing in a machine learning problem statement we do is we understand the requirement, and we understand the need, and we understand the feasibility. Whenever you learn machine learning, nobody talks about that. Even I take a lot of machine learning courses for students, and even I don't talk about that because they are limited hours courses, 10 hours, 15 hours, 20 hours. We talk about technology, we don't talk about the business side of it. But when you approach it in business, you don't want to spend 30, 40, 50 hours working on a project and then realize that this is not even possible. So the very first thing you should be doing is checking the feasibility, checking the requirement. The next thing you do is you collect the data. Now, this point can go a little against your standard belief. A lot of academic people, a lot of students think like you will go to Kaggle and you will download the data and then you will pass it to a dot fit function and it will work. It's not like that. If you are planning to spend 3 months on a machine learning project, trust me, you will spend more than 1.5 months only and only to collect the data. Two reasons for that. One, you need volume of data, and two, you need a very specific data. I'll give you an example from India once again. There's a company in Delhi called as Chios. Most of you might have heard of it if you are from Delhi NCR. It is in different cities also. So Chios is a tea brand, as the name, the word chai, which is Hindi word for tea. So if you are not able to relate to it, you can imagine Cafe Coffee Day or Subway or McDonald or any of them. Basically, the example is for Chios, but you can imagine any other country. I was working with Chios, and the task given to my team was to reduce their dustbin ratio. What is dustbin ratio? These standard their standard operating procedures ask them to throw something beyond a 48 hours of time stamp. So if they make a sandwich today, or just now, if they make a sandwich at 12 noon on Saturday, they are not supposed to use it after 12 noon of Monday. Okay, as per Chios, different companies can have different timestamps, but they are not supposed to use it even if they have 10 customers in front of them and they don't have any fresh sandwich. They are still supposed to throw that. So this is called as dustbin ratio. That if they are making 100 sandwiches, their number was 4.5. That 4.5 are going to dustbins. So they wanted to reduce it. Of course, the very first question I asked them was, "What's your problem statement?" That was clear. That was kind of feasible also, that we need to actually predict the demand and accordingly we need to produce the supply. But the next question was, "Do you have data?" And the answer was sure no, that we do not have any form of data. We do not have any CRM. We do not have anything. The only thing we have is our billing software, and which is a third party software which does not allow us to store or get the data at a later stage. That's a big full stop for me to proceed with the project. And this is a real example, by the way. So we need to spend some 3 to 4 months, wherein in the initial 1 week we built a tool, a data collection tool. We connected that to their billing system, and we just waited for 3 to 4 months for a lot of data to be collected. Every time they are making a sale, our CRM was getting the data, their billing system was processing the bills, and we were doing nothing. We were just waiting for a lot of data to pile up. In next like 3 to 4 months, imagine like Chai was doing some 500 transactions in a day. We got 500 multiplied by 100 days of data approximately, and that was a decently good number to start with. So the very first thing, again, you should be focusing on after requirement gathering is, what's my source of data? Do I have data? Do I have to generate the data? Will I get the data in a structured format, or will I get the data in a non-structured format? Is my data authenticated? Is my data actually correct or not? I believe I'm clear so far that what exactly is the meaning of collection of data and why it's important. A quick yes on the chat if you understand this. Okay, anybody have any question? Perfect, perfect. I got a lot of yes, yes, yes. Thank you so much. Okay, so the next thing, once you get the data, then you should think of working with any of the tool you have learned, like Python, R, MATLAB, Matplotlib, or anything you know about. That's where exactly you should be starting up with that tool. A lot of things before that, whatever we have discussed, these two steps should be on a paper pen or a PPT or some kind of managerial tools, not on any coding tool. Once you get these two steps done, then you should think of that I am a data scientist or a machine learning engineer. I do my work using Python or R, or so I do my work in Python. So what I will do in any of the scenario is, I will, once I got the data, I will load my data into Python. I believe if you know machine learning, you know this step. You'll use pandas, you'll load the data using read CSV in most of the cases, or read JSON or read TXT or whatever way. So I will not stress much upon the technical steps because they are like part of every single course you go through. My stress will be on those steps which are not very clearly taught about. So you will load your data. Once you load your data, a lot of people just start doing technical things. How do you identify the features to collect? Again, that's about your requirement. What are your requirements? And in the initial stage, you actually correct everything, anything and everything that comes your way, because you really don't know what could be relevant and what could not be. The problem statements can also change at a later stage. Chios can come and say that, hey, okay, you got this problem solved, now solve our second problem. Then we cannot wait for 3 or 4 months again to collect the data. If you're collecting data, we should collect like everything. Storage is very cheap. Like you get 1 GB of storage and hardly 1 rupee when you buy servers or large size hard disks. So that's very cheap. You can just collect anything and everything that's coming your way. So once you got your data and once you load it in Python, do not feel eager to start doing something on your data. Do not feel eager to clean process. Okay, you have this function and that function in your knowledge and you have to apply it. No, hold on. Firstly, spend some time and understand that data. Firstly, understand, is that data correct or incorrect? Is that data relevant or irrelevant? Sometimes your correct data can also be irrelevant. I'll give you an example. So uh, let's say make my trip. I believe all of you know, those who are from outside India, those who are from Africa, UK region. Thomas Cook is the next example. So they are travel companies, and these travel companies usually comes up with discount coupons. And let's say you are the make my trip machine learning engineer, and the task given to you is to find out how much percentage discount coupon should we launch. Should it be 5%, 10%, 15%, or what? Of course, you can launch a 100% discount coupon. Customers will be benefited, but you will be in loss. And you can launch a 2% discount coupon. You will save your money, but customer will not be benefited. So you need to find an optimum number of percentage where the customers will also get the benefit, and you will also be able to manage your finance. So in order to decide this, you roll out a survey form and you ask people for where you are from, what do you do, what's your salary, what's your net worth, how frequently do you travel, in which class, like first class, premium, business class, in which type of transport mode you travel, etc. And you get a lot of data. Wherein, if I talk about in Indian rupees, average annual salary of people are like 5 lakh, 4 lakh, 6 lakh, 10 lakh. And all of a sudden, you see somebody's average salary is like 100 crores. Two reasons. One, that is accidental. The person could be accidental or could be intentionally wrong. The person is just mocking with you. Like so many times we see a form and we have no interest to fill that up and we fill random value. Could be it is accidental. Maybe the person wanted to write 100,000, which is 1 lakh, or could be like 10 lakhs, 1 million, but the person accidentally wrote like 100 crores. Or could be the person's actual salary is 100 crore. What if Elon Musk is filling your form? But for any which reason, for whatsoever reason, because you are not launching a coupon code for Elon Musk or Jeff Bezos or Mukesh Ambani, you need to ignore that value. You should not be considering that, okay, is this right? Is this wrong? What if this 100 crore is a right value? True, that could be right, but that person is 100% not your customer. If a person is having 100 crores of annual salary, and those who don't know what's 100 crores, it's like 1000 millions. Okay, maybe like 1 billion. 1 billion Indian rupees. So whatever the higher value is, that person is not your target customer. You are not making your decisions according to that person's salary, because if you do launch a coupon code for a person who is having 100 crores of salary, you are completely deviating from your data collection requirement. You are supposed to launch it for the common people who may have a salary of 2, 3, 4, 5 lakh rupees per annum, or maybe half a million Indian rupees per annum for those who are outside India. Okay, so you should spend a lot of time finding your outliers in the data, finding the types of data, finding the patterns in data. One more thing, like people don't understand, there are 4 categories of data. If you know or if you don't know, I'm typing it down on chat. It's called as NOIR, where these are acronyms. So N stands for nominal, O stands for ordinal, I stands for interval, R stands for range. Nominal and ordinal. Typically, we classify data into 2 parts, discrete and continuous. Can you also elaborate more about forms of data collection? Actually, there are no static ways. Like there can be anything and everything that comes your way. You may need to sit, being a typewriter, you need to type data. At times, you may need to build APIs. You may need to connect to pre-built APIs. You may need to download data. There are a variety of ways. Like there are no static ways. More information you have about it, as much information you have about it, that's going to help you. If you are also a web developer, it will be very easy for you to build APIs. If you are not a web developer, you may need to hire somebody to build APIs. Basically, you need to have a lot of options in front of you while collecting data, and case to case basis, it will differ. but very rarely you will get a CSV pre-built that, okay, take this and do the work. Whether it's a startup or a company like Cisco, people firstly do not have the data, and secondly, people don't want to share the data. So you need to generate your own data. That's like the bad thing about data science. Okay, coming back to the acronym part, NOIR. So typically we divide our data into two categories, which is discrete or categorical. Discrete or continuous. But we forget to divide it even further. When your data is discrete, it can still be divided into two parts. One is called as nominal and one is called as ordinal. I'll give you an example. I'll ask you a question that there are five names written. Let me pick five names from the attendance this webinar. Let's say it's Aditya, Aparna, and Jerry, and David, and Chandra. Okay. Can you order them in such a way that it reflects something about their personality? The only thing, or the only way you can order is maybe alphabetically, or maybe the time they have joined this meeting, but you cannot actually order them in any such way which reflects some information, right? If somebody's name is Chandra and the initial word is C, that does not reflect anything. If somebody's name is Daniel, that does not reflect anything. You cannot put this logic that D comes after C, so Daniel's height must be higher than Chandra's height or anything like that. This is like not making sense. But if I give you another categorical data, by the way, this name is a categorical data. If I give you another form of categorical data, let's say I have three air conditioners in my house. Example. One is a 5-star air conditioner, one is a 4-star air conditioner, one is a 3-star air conditioner. Can you imagine some sort of order in your mind about them? Actually, yes, you can estimate the order of their price. The 5 star AC must be expensive than the 4-star and 3-star AC in a conventional way. It's possible that the 3-star AC is an imported one and it's much more expensive, but in a general conventional way, it's supposed to be cheaper. The 5-star AC is supposed to have higher lifetime. The 5-star AC is supposed to consume lesser amount of electricity. The 5-star AC is supposed to, look better than a 3-star AC, again in a conventional way. So these are few personality traits, so to say, about that data you can develop from the order that is mentioned. So sometimes the order of the data reflects something and sometimes it doesn't. If it reflects, and I'm talking only about categorical data, by the way, right? 5-star, 4-star, 3-star is categorical, it's not continuous. Names are also categorical. If the order of the data is reflecting something, that is called as ordinal data. That's why the name ordinal, coming from the order. And if it is not reflecting something, it's called as nominal data, because most of the time these things are actually your names, email IDs, PAN numbers, Aadhaar card numbers, passport numbers, etc. So they are called as nominal, NOMINIL, sorry. Okay. On the other side, when you are into when you are into continuous side, there are again two forms of data, interval and ratio. I'll give you an example for both of them. Let's say I say my age is 25 years and my brother's age is 22 years. Okay. Will you, or let me say my age is 25 years and my brother's age is 5 years. And I give you two options to pick from. First option is, will you say I am 5 times elder to my brother? Or will you say I am 20 years elder to my brother? Pick the option, A or B. B. A lot of messages for B. Why? Because the equation 5 times is just valid for now. Next year it will change. I will be 26 and he will be 6. Now the 5 times doesn't hold valid. But the equation of 20 years elder is going to be fixed, because the difference in our data is not of a ratio type, it is of an interval type. We have an interval gap of 20 years, which will remain constant throughout the life. But on the other side, if I say I earned 5 lakh rupees this year and I have to pay 15 lakh rupees of tax, that's 30%. Okay, sorry, not 15 lakh, 1.5 lakh rupees of tax, that's 30%. And do you count the taxes as a ratio or do you count it as an interval? Will you, if your income increase 1 lakh by the next year, will you increase your tax by 1 lakh or will you increase it as a percentage of 1 lakh? That's where your ratio types comes in. So whatever type of data you have, Firstly, divide them, and you don't need to have a tool or a technology or a function for doing this. It's your understanding. When you have a data, firstly understand whether it is categorical or it is continuous. If it is categorical, understand if it is nominal or ordinal. If it is continuous, understand if it is continuous or sorry, there are a lot of tongue twister. If it is continuous, understand if it is in interval type or in the ratio type. That will give you a lot of sense, a lot of information about what to do with such kind of data. Okay, moving ahead, you need to check outliers, you need to check the authenticity of the data. What could be an example of authenticity? Let's say you are, I'll give you a cliche example. That's a data on Kaggle, and the data is about taxi fare prediction in New York. Most likely, many of you might have touched upon that data earlier. So the data and the task is about predicting the taxi fare in New York City. And there are a lot of information like the pickup longitude, latitude, the drop off longitude, latitude, and how many passengers, what was the time of the day, what was the day, was it Sunday, Monday, Tuesday, etc., and so many other things. Now, if you are doing an analysis of New York and you find a longitude, latitude of India or of Dubai or of UK or any other city in USA, that is purely invalid, right? Now, by looking at a number, you will not realize that this is an invalid number, but you need to put your domain knowledge, your overall understanding, your brain onto work as a data scientist to firstly study what are the longitude, latitude range of New York City, and then to filter your data that is there any longitude over and above this or below this? Is there any latitude above this or below this? And if there are, you need to discard those data or you need to rectify those data, because those data are not talking about New York. Could be accidentally they are wrong. They were part of New York, but somebody changed their longitude, or could be they are like misplaced here. Okay, but for whatever reason, they are not valid data points. So you have to clean your data. You have to check whether my data is purely cleaned or not. I divide it into two parts. In the first phase, I call it EDA. I observe everything. I don't perform anything. I do a lot of read-only tasks. Like I plot graphs, I plot distributions, I check the statistics, I check the frequencies of everything occurring up, I check the minimum, maximums, outliers, etc. And then I just note down things on my diary, on my paper. In the next, this is called as EDA, exploratory data analysis. This is third step in my series. First step is requirement gathering, second step is data collection, third step is EDA. The fourth step is I will act upon the results I have received from EDA. I will clean my data, I will remove the outliers, I will replace the values, I will remove the missing values, I will fill up those values, etc. etc. Okay, I'll act upon curating those problems which I found out on EDA. What could be the next step? Anybody? The next step is very conventional. I believe all of you know about that. You will split your data into features and labels. You'll separate your features with your labels. Okay, you do a vertical split in which you say that, how do you do that? Very simple. There are drop functions for that, or there are column selection operations for that. One of any of them, you can use it. And the next step you do is you do a train test split. Again, that's where you need to make a decision that what kind of mechanism are you going to pick for train test split. Are you going to do it in the conventional way, like a random train test split? Are you going to use k-fold? Are you going to use stratified k-fold? Are you going to use splitwise k-fold? Are you going to use leave one out k-fold, etc.? There are so many options for that. Just give me a minute for turning off the video. Okay, there are so many options available for that particular purpose, and you need to decide on the basis of your understanding of two things. One, how well do you understand data? And from where your answer will come? From the third step, that's EDA. How well do you understand data? One. Secondly, how well do you understand each of the operation? So whenever I start a machine learning course or somewhere in the middle, I very frequently give this example. Suppose you have to go from suppose you're a king or a very rich person and you have so many cars with you, and you have to go from New Delhi to Bangalore. Those who don't know what is New Delhi to Bangalore, like you can imagine any two far distant cities in your country. Okay, for example, New York to California or any other two countries in any country. Now, which car will you pick? It will depend on your understanding of two things. First, how well do you understand terrain? Do you know what kind of terrain you are going to face from New Delhi to Bangalore? I am from India. I have worked in Bangalore. I have worked in New Delhi, and I have traveled a lot. I know that it's a kind of plateau terrain. It's most of that is the urban area. So I will pick a car which is more suited for urban areas. Okay, for developed areas. I will not pick a an off-road car, or I will not pick a very high speed sports car or anything like that. I'll more likely pick a sedan or a hatchback or an SUV something. And the second thing is, how well do you understand your car? You know that it is a terrain which is made up of a lot of urban roads, high quality roads. But then do you understand things about your cars? Do you know which car is suited for long drives? Do you know which car is suited for cement roads, and which car is suited for Dharma roads, and which car is suited for desert roads, and which car is suited for icy areas, and which car is suited for mountains? Those are the two things which you need to understand. Same here. One question is, how well do you understand your data? Are there any slides for the webinar? Actually, no. I do not ever go with slide, whether it is corporate training or student training. So first thing you need to understand is, how well do you understand your data? That's your terrain. Okay, which terrain you are operating in? Is that a clean data, balanced data, imbalanced data, not clean data, skewed data, or what kind of data it is? And the second thing is, how well do you understand your vehicles? That's your machine learning algorithms. Which kind of split will you use? Which kind of regression model will you use? Which kind of classification model will you use? So by an understanding of both of them in a deeper context, you will be able to make up a good decision. Somebody just asked me for splits, that which is the best split model, something like that was the question. I didn't see the exact wording. I'm still Which would be a good approach for splitting? This is the exact question. So see, there is no best approach, so to say, because imagine there is a best approach, then the other approaches must not be existing. Everybody will use the best approach. The art in machine learning is to pick the option among the 5 or 6 available options. Pick the right option. That's your task. It's called as data science. It's not called as a data technology. It's science. It's an art. That's why people are getting paid very much higher, because if you talk about the code, it's just a 15 line of code which can predict things, but it's the content in those 15 lines, like you are picking what kind of model and why, you're picking what kind of operation and why, you're picking what kind of split and why. That's why you're getting paid higher than other people. Okay, moving down, once you got your splits done, you will pick a machine learning model. How do you pick a machine learning model? First way is your knowledge. How well do you know about each of the model? How well do you know about each of the algorithm? Do you know what is the difference between logistic regression and SVM? Do you know how KNN operate? Do you know how decision trees operate? Do you know how gradient boost operates, etc.? And again, how many algorithms do you know? Suppose I am a middle class person and I have a single car. I don't have options to pick from. The only option I have is, if I have to take my own car, there's only one car. And then I am a slightly rich person, I have 3 cars, and I have 3 options. But if I am like Vijay Mallya or Mukesh Ambani or Elon Musk, I have like plenty of cars to pick from. I can demand for what car I want. If I want the sports car, I have the best of the best sports car in my gate. And if I want a limousine, I have the best of the best limousine available. So here, your money should be replaced by your knowledge. If you are a beginner, you may have 2 or 3 algorithms only to pick from. If you are an intermediate person, you have 5 algorithms. If you are a person with my level of experience, you may have 20 algorithms. If you are a person with higher experience, you may have 100 algorithms to pick from or to customize from. But there is one thing that can help you to pick among the given option. It's your task to bring the option, but there is something called as grid search cross validation or randomized search cross validation that can help you pick from the given option, that given this data, what is the best algorithm to use. Again, please listen to my words. Given this data, what is the best algorithm to use? I have added the word given this data. Okay, it's not like the globally best algorithm. On every data, there can be different algorithm which will work. You have to figure out using grid search cross validation, which is nothing but it will perform a lot of operations. It will calculate every single combination's accuracy or loss, and then tell you that this is the best performing model and you should pick this. So grid search is your word to search for. I'm giving you a lot of words to search forward for. Okay. Once you got your model finalized, you need to tune your model. You need to finalize what are the hyperparameters for that. If you don't know if you don't know about hyperparameters, you say model is equals to svm and model.fit. That means you are using the default settings of svm. There are so many things you can customize inside svm, and svm can give you 80% accuracy, and the same svm, if you customize a little, can give you 95% of accuracy on the same data. So there are parameters you need to tune. There are a lot of configurations you need to make. Again, grid search is going to help you out, and your information is also going to help you out there. Once you get it done, again, a very cliche step, model.fit. You train your model. And by the way, like whatever we are discussing, it's just not there for machine learning. It is there for deep learning also. It's the same process. Until data, everything is same, split is same, finding the deep learning model is same, tuning the deep learning model is same, training the deep learning model is also same. Okay. And then you go forward for training the data. Once you train your data, you have to validate your training results. Please listen to me. You have to validate your training result. Training is the word here. So you train your data. It is like, I'll give an example. So let's say you are teaching a kid how to perform mathematical addition, and you teach like 2 plus 3 is 5, 1 plus 1 is 2, and 1 plus 4 is also 5. And now you ask a kid a question that what is 1 plus 1? The kid may give you two answers. Either the kid will say 2, or the kid will say anything apart from 2. This is called as training evaluation. Why it is training evaluation? If the kid said anything apart from 2, it's 100% clear the kid have not learned. But if the kid says 2, it's still not clear that the kid have learned. The kid may have crammed the things because you have told the kid 1 plus 1 is 2. And maybe the kid just have crammed. The kid doesn't know how to calculate that. The kid only knows that, okay, 1 plus 1 is 2. That means it is 2. Now 1 plus 2, I don't know, because that is never discussed. Okay. This is where you will get a filter that, okay, whether my model has understood the training data or not. If my model has not understood the training data, I have to change things. I have to go back to the very first step. Maybe my data collection is wrong. Maybe my requirement understanding is wrong. Maybe my EDA is wrong. Maybe my processing is wrong. Maybe my split is wrong, etc. Or maybe my model is wrong. Yes, somebody said undercutting and overfitting. No, it's underfitting and overfitting. Yeah. So, but if training performance is good, that does not give you the answer that your model is good. It can be cramming, which is also called as overfitting, or it can be actually good training. Okay, so how will you test that? You will ask a question which is never discussed. If you assume that your kid has understood addition, you ask him what is 8 plus 1. If the kid answers you 9, that means the kid has understood things. If the kid doesn't answer you 9, that means the kid has not understood things. Okay. Virendra, I will take your question or anything. Please give me some time. I saw your hand. Keep your hand raised. I'll take your question. So now, how will you get this question 8 plus 1? Since it is addition, you can curate and create any number of questions. But when you're talking about data, you have limited data with you. Let's say 500 records. So that's why split was important. You will firstly split your data into like 400 and 100. You will train on the 400 parts, 400 records, and you will test on those 100 records. That's how you validate on the test data. Once your validation fails, you need to go back to the start and repeat everything. But if your validation succeed, that's again a point which most of the students do not do, is to save your model. A lot of people do not write the code to save the model. You need to serialize and save your model using packages like pickle, joblib. In machine learning, in deep learning, TensorFlow gives a package like .save model, and there are like various other ways, but you need to save your model to keep it permanent. You just can't keep it like a variable, because that will be lost once you have got the training completed. So you need to save your model, and once the saving is done, you need to deploy your model to whatever purpose you have built it for. Have you built it to make a website out of that? For example, Facebook. Is Facebook a website? Technically, yes. But is Facebook famous because of website? No, Facebook is famous because of their artificial intelligence. It is famous because of their high quality recommendation system. Netflix and YouTube is famous because of their high quality recommendation system. They are not only video hosting platform. There are many like that. It is famous for the recommendation they are giving you. It is famous for analyzing your profile very well, much better than any other platform. So that's how their models are deployed and working. So you need to deploy your model in the form of a mobile app, web app, game, software, API, whatsoever. For that, again, you need to take help from people who are working in that domain. If you are deploying it to a website, you need a web developer, or you need to learn web development by yourself. So if I quickly summarize all the steps one by one, and then I'll take your question. All those who have questions, please raise your hands. I'll take your question one by one. I guess chat is not a feasible option to take questions from right now. I'll give you audio access to ask the question. So first step, understand the requirement. Second step, collect the data. Third step, analyze your data, perform the EDA. Fourth step, act upon that EDA, process your data, clean your data, transform your data, do whatever is required. Fifth step, split your features and labels. Sixth step, split your data into train and test using variety of options available. Next, find your right model. Next, tune that right model. Next, train your model. Next, check your training performance, then check your testing performance. If any of them is not working, go back to the start and do things again with different combinations. But if both of them are working, save your model and deploy your model. That marks the complete end-to-end pipeline of machine learning. And that's how exactly an industrial project is being taken care of. Not like you would go to Kaggle, you download the data and you load it and you do model.fit and ta-da, it works. No, it doesn't go like that. There are a lot of things you need to do before actually getting the data. Getting the data is like 50% of the task completed. So yeah, this is all about things from my side. Kaggle has toy data sets. Yes, it is a very good platform. By the way, I'm not criticizing Kaggle. What I'm saying is, if you have to analyze Amazon, you need to get data from Amazon. You'll not get the data from Kaggle. If you have to analyze Cisco, you need to get the data from Cisco. If you have to analyze Flipkart, you need to get the data from Flipkart. So not from Kaggle. Kaggle is like a general public data. It's a mock data to practice. It's a very good platform to practice. I have practiced from there. All of you must have practiced from there. Everybody learns things from Kaggle only. But like again, when you do things for production, when you do things which makes money for companies, you need personalized data. When do we use hyperparameterization? I guess you're talking about hyperparameter tuning. It is the same thing as grid search. When I said tuning the model, once you get your final model ready, that okay, I am going to use SVC or KNN or decision tree, then what parameters of decision tree I will use? What will be my max depth value? What will be the min left value? What will be my n value, etc. So that's how you do with grid search and randomized search. If I know machine, all those who have questions, you can put down on chat. I am looking at chat right now, only at the new questions. A lot of questions have skipped up. I'm really sorry for that. If I know machine learning, how to start with deep learning? Like, if you know machine learning and you have done 3 to 4 projects at least, you can keep going with deep learning. You can take up a course, or you can follow YouTube. You can follow Google. There are so many things available. Or you can like follow documentation of TensorFlow and start learning from there. How to know which algorithm fit for our data set? It's again your knowledge about your car and the terrain. That same example. So there is no right or wrong answer to that. Everything works, but like you need to put your experience on work on that place. Grid search can help you a little on that. How to check for data drift? What do you mean by data drift? Do you mean the skewness or imbalanced data? Ramesh, please answer me this thing, then I will answer your question further. Keshav asked if two different algorithms are giving similar result, then how to make a choice? Again, like I'm saying, if you drive a car for 100 meter and you drive another car for 100 meter and they come up with the same kind of performance, it's your experience with those car which will help you choose which car to go forward. You cannot just have a global answer for this thing. No algorithm is better than another algorithm. I have seen logistic regression performing much better than any other complex algorithm, even random forest. I've seen logistic regression performing better than random forest at variety of cases. So it's not like logistic regression is a basic algorithm, random forest is a complex algorithm. Please scroll up. I have a long question. Imbalanced data. Okay, so Ramesh, there is something called as kurtosis to check for imbalanced data. That will help you out. Skewness and kurtosis is what you can check forward for. Change of data with time or environment is equals to data drift. I got it. I got it. That kurtosis and skewness will help them out. What are some good resources for guided ML projects using Python to learn more about ML and how to apply them? YouTube, I guess, is a very good platform. There are like enough of channels about Python and machine learning on them. We are on the platform of Analytics Vidhya, so I believe Analytics Vidhya. Honestly, I'm not promoting, but honestly, I have spent a lot of time on Analytics Vidhya while I was a student and I was learning. Even now, sometimes I look forward for articles, and they're really good. So this is a good platform. Any tips to find and work in industry level project like uh, uh, it's like you cannot, because you cannot get the data is like a very secure thing. Nobody is ready to, even if you go to Amazon and you say that, hey, I'm going to work for you for free, they'll not give you data. So it's difficult. If you can actually find some connections and if you can find some startups, that's the only way, I guess. But otherwise the traditional ways, do something good in machine learning, get into a job or an internship and get the access to data and work there. That's like, I guess, a good way. So I'll scroll up. There was actually a very big question. Let me have a check.
Yeah, hi Harsh. Actually, I copy pasted it again.
Okay, perfect. I'll just check it. 1 second. Pranav, you have raised your hand. Have your query got solved? Please put down on chat if it is not. How can we approach an industrial problem where our agenda is to predict whether our particular task is going to run into a problem or not? The challenge here is that we have only 6,000 of data to build the model, plus the data we have. Okay, I don't know who asked this question. Raksha has just posted it up. It looks like a consultancy task. There is a lot of information. I need much more than this. And moreover, your message seems truncated. It's given till all the data is categorical. So there is a lot of things. I guess it will take a lot of time. I would suggest you reach out to me on LinkedIn. I'll try to answer your question there better rather than spending a lot of time here. And one more thing, I'm putting down my LinkedIn here. So all those who wants to connect, you are more than welcome. 1 second.
And Harsh, actually, sorry to interrupt. I have one question from my side.
Sure.
So actually, how far it is good to transform the target variable, and if we do any transformation on target, then how to bring it back to its original form?
So it depends on how are you transforming. Are you transforming using the conventional method like label encoder or one-hot encoder? If that is the case, then they themselves provide a reverse mechanism for getting the result back. Like label encoding has their own reverse mechanism, and one-hot encoding also have their own reverse mechanism. That the way with which you can reverse it. But if in case you are not using the conventional method, if you are designing your own function, then you need to design the reverse mechanism also, like the reverse map function for that. So that's how you can get the answer in reverse. That's your second question. Sorry. And your first question is how good it is. Just a minute. Sorry, so I'm really struggling from my cough and cold. Okay, so how good it is to transform the label? Is that your question, right?
Yeah, your target variable, how
Target
far it is
variable.
good to.
So there is no harm in doing that until you are preserving the nature of that. And what do I mean by nature? So a lot of time when we try to convert the categorical values into numerical values, we lose their sense of being nominal or ordinal. We should treat the nominal data and ordinal data differently. We shouldn't treat just discrete data in a similar way. Discrete can be nominal, can be ordinal, and both of them should have a different treatment. Nominal should be transformed in such a way that after transformation, it is also nominal. Same with ordinal. Ordinal should be transformed in such a way that after ordinal also, it should be ordinal only. If you are maintaining this, then you are good to go. But in my opinion, you really do not need to transform labels at all, because labels do not go as input. Labels are not used to find and predict the patterns. They are just the mapping value. And even if it isn't text, I guess a lot of models can accept it.
Yes, so like generally after generating predictions, we need to bring it back to its original form.
Yes.
Suppose we
So
did log transformation or a square root or something like that. So like, is it not a wrong way to do?
no, no, that's absolutely not a wrong way. One thing, if you are preserving the nature, then nothing is wrong. But if you are losing out the nature, then of course things will go wrong. And another question, like after prediction, you need to change. Yes, because your machine learning algorithm is designed to predict for the numerical value. Once you got your numerical value predicted, pass that numerical value to a reverse mapping function, and that will give you the reverse answer. Like suppose 5 means apple and 10 means elephant and 2 means
Yeah.
banana and so on.
Mm-hmm.
Okay. So you
Okay.
predict for a number. Let's say the number predicted out is 5. Pass that number to a reverse map function, and that will give you the elephant or apple or whatever is the mapping value.
Okay, that's
Aparna
interesting.
is concerned about my health. Thank you so much, and we can hopefully have more such sessions in the future. Thank you so much, Aparna. It is really kind of you. But yeah, I'm fine. Like it's just regular cough and cold. Okay. Any more questions? If I skipped out, please. I am so sorry. You can post it down here, and I will answer it. I guess we have 5 more minutes. I really hope you liked the session. I really hope I was able to give you some value in 1 hour. It was very, very fast. I have to keep it fast and continuously going because of so much of content to cover. And I wish I justified with the title itself.
Yeah, definitely. And thank you so much on the behalf of Analytics Vidya as well. I would like to thank you. You have delivered such a great session, and I was excited to attend this session because yeah, it was very basic, but it was like it's a great thing to understand how to approach problems. And
It's
you really answered like I have a few doubts regarding that, and it was cleared in this session. So thank you so
perfect.
much. And I'm sure it was appropriate for lots of experience levels. And hopefully we can conduct more sessions with you in the future.
Sure, and I will be happy to do that. I got few questions. Let me answer that. So it's by Shankar Sahu. It says any article you suggest for this relevant topic. I guess there are not many articles about this topic. That's why I chose this thing. Even if there are, they are not very much promoted like Medium articles or Analytics Vidhya articles. There are not many articles on this. I would suggest Analytics Vidhya to write something on that, or I would write something like this on some platform myself, and then I can share you. Even if there is, maybe there are, but I am not aware of any such article right now. Google can help you, right? Ashok Puri asked, when do you decide for ensemble model? So my journey is like that. Whenever I develop, I ask myself a question that is that a regression and or classification data? That's a fairly basic question. If the answer is classification, I decide whether this data has higher correlation or low correlation. For example, I'll give you a very simple example rather than a complex one. You see Titanic data in Kaggle, very, very common and simple data, but none of those columns actually have higher correlation with the survived column. None of those columns, if you pass them to df.corr function, none of those columns actually have higher correlation with the survived column. And there are a lot of production grade systems when you think the data is correlated, but data is not. So in those scenarios, I start my journey with at least random forest, and then I go forward with gradient boost and ADA boost and XG boost and all of them. If the data is correlated, I don't really touch them. I keep myself very simple with SVM or logistic and so many. I have like a flow which I follow, and that's how I decide the algorithms. Would love to connect with you over LinkedIn. Sure, Pranav. I'll expect your connection request, and I would be happy to connect. It was filled with very real examples, so truly useful. Thank you so much. And I hope this will add information to your knowledge and your value system. And I wish you very good luck for whatever stage of life you are in. You're a student or working professional or startup enthusiast or businessman or employee intern, whatsoever is your stage of life. I wish you very good luck for that. Thank you so much. And anything else you want to ask me, you can. I guess we are done for the session. Thank you, Raksha. Thank you, Saubhagya, for hosting it up, and thank you all the participants who have taken out time on a festival season.